Hello students, very good evening to all of you. So today I will cover the PYQ of the principal stresses and strain. Some of the questions I have covered in my earlier lectures. So today I will cover additional questions pertaining to engineering services and GATE, as this chapter is very important and regularly we will find questions from this chapter in GATE and engineering services. That's why I am taking this second part also to have a clear understanding of the questions. So let us start one by one. This is a question of engineering services 2002. Consider the following statement. Mohr circle is used to determine the stress on an oblique section of a body subjected to drag tensile stress on one plane accompanied by shear stress, drag tensile stress in two mutually perpendicular directions accompanied by simple shear stress, drag tensile stress in two mutually perpendicular directions, a simple shear stress. Select the correct answer using the code given above. So, in case of Mohr circle, it's not a simple shear stress. So, yes, drag tensile stress on one plane, drag tensile stress on one plane accompanied by shear stress, like this. We can draw Mohr circle for this. Drag tensile stresses in two mutually perpendicular directions. Yes, accompanied by shear stress. We can also draw Mohr circle for this case. In the third case, drag tensile stress in two mutually perpendicular direction. Yes, if you want to know the drag stress on this and the another plane, we can find from the Mohr circle. A simple shear stress, a simple shear stress or in case of simple shear stress like this, so we can it can be used to determine the stress on an oblique section of a body subjected to simple shear stress. So simple shear stress means in this case we can, although we can draw the Mohr circle for pure shear, but in case of simple shear generally it is not required. So option is this one. A bar, this is a bar, and compressive direct compressive stress is there, having an area of cross section. Area of cross section is, this area is A, and it is subjected to this compressive load. So stress will be equal to load upon area. This is P upon A. So we have to find the intensity of the tangential stress on the oblique plane, on this plane. On this plane, tangential stress will be equal to so these are options. Now if this is theta, this angle is theta, so this angle will also be theta, and this is a compressive stress of P upon A. So in this plane, its component will be P upon P upon A. This is equal to cos theta. So it will be, this stress, tangential stress will be P upon A cos theta. So it will be P upon A cos theta. So this is the stress on this plane. As we know, stress on this, if I resolve it, this will be, this is the P, and it is acting on this one. This is P upon A, and this will be P upon A. Is P. So in this case, option is, this is P upon A 2 sin theta cos theta. So this is, I think some mistake is there in this. Let us start again. A bar of square cross section having an area of cross section, this is the A, and on this plane I have to, let us, I can say, if this is theta, this theta is also equal to theta, and my rotation is clockwise. If I want to draw the Mohr circle, then on this plane my stress is P upon A, and on this plane it is 0, and shear stress is absent. So this is my Mohr circle. So if I want to know the stress on this plane, so this is a theta is, this theta is clockwise rotations. So this is the center of the Mohr circle. This distance is half of this. This is P upon A, half P upon 2A. So this will also be, this is the radius P upon 2A. So this is P upon 2A, and the rotation will be 2 times. So it is clockwise rotation 2 theta. So my normal stress will be, tangential stress means this component. This component, this is for tangential stress. So this will be plus, and this is P upon 2A into, this will be the sine of theta. So P upon 2A into sine 2 theta. So this is the right option. P upon 2A sine 2 theta. This is the right option. If P1 and P2 are two equal tensile principal stresses on the plane AB inclined at 45 degree to the plane of P1, if this is 45, this is also 45. So the shear stress is maximum on the plane, this plane, on the plane AB inclined at 45 degree to the plane of P1 as shown in the figure. The shear stress is maximum, the normal stress is 0, the shear stress, what is the option? So if I draw a Mohr circle for this, then it will be like this. This is P1 and this is P2 on this plane. This is P1 and this is P2. So half of this will be the Mohr circle. So this theta is 45 degree and this is anticlockwise rotations. So 2 theta means 2 times of 45 degree means 90 degree. So from here it is 2 theta means 90 degree. So this 2 theta means 2 into 45. This is 90 degree. So at this point, what is maximum? This represent my shear stress. So on this plane, shear stress is maximum, and this is my normal stress. This is half of this P1 plus P2 by 2. So at this, on this plane, my shear stress is maximum. So it means this one is the right option. The principal strain at a point are 800 into this one. These are the principal strain. The volumetric strain is equal to how much? So volumetric strain is EV is equal to EX plus EY plus EZ, means sum of the strain in the 3 directions. So sum of these 3 will be, this is 800 plus 800 plus 400, it will be, and this is minus 1200 raised to the power 10 raised to the power minus 6 centimeter per centimeter. So this is 1200 minus 1200 means 0. So volumetric strain will be 0. So this is the right option. The radius of a Mohr circle is 0 when state of stress is such that shear stress is 0, there is a pure shear, there is no shear stress but identical direct stresses in two mutual perpendicular direction. And there is no shear stress but equal stresses opposite in nature in two mutual perpendicular directions. So in this case, the radius will be 0. So this is like the two equal direct stresses. Suppose this is P, this is P, and opposite in nature means this is P tensile and here it is P compressive, and no shear stress. No shear stress means these are principal planes. So this is P tensile, opposite in nature. So in this case it will be P, this is P. So this will be my Mohr circle. So radius is, there is a radius. So this is not the right option. In this case there is a no shear stress but identical direct stresses in two mutual perpendicular direction. Like this means identical, this is P tensile, this is also tensile P, and no shear stress. So if I draw the Mohr circle for this, it will be P. On this plane it is P, and on this plane also it is P tensile, means it is same, and shear stress is also 0. So it means my Mohr circle is just a simple a point. So radius here is 0. So this point itself is a Mohr circle. So this one is the right option. This is a case of pure shear. The given figure shows that stress condition of an element is this. The principal stresses are which one? So if I draw a Mohr circle, then on this plane this is upward, means positive. So this is tau, and normal stress is 0, means this is the point. On this plane this is negative. Oh, this is positive, means it will be tau, and on the negative side it is this. So this is tau also. So if I draw a Mohr circle, then, and this is the origin and this is the radius. So this will also be Q, this is also Q. This is plus Q tensile on the right direction of the origin, and this is minus. So plus minus, oh, this is tau, plus minus tau will be the direct stresses. So these are my principal stresses, where shear stress is 0, means this principal stress sigma 1 is equal to plus Q tau, and this sigma 2 is equal to minus tau. It means plus minus, these are my principal stresses. It means this one is the right option. If the principal stress is at a point in a stress body are this and this is compressive, this is tense, then maximum shear stress is, so like this is my Mohr circle origin. So this is 150 tensile, and this is compressive 50. Maximum shear stress at this point will be, these are the principal stresses, means no shear stress. So this is 150 and this is 50 kilonewton per mm. This one is compressive. So it is on the left hand side. This one is 50, this is 150. So these are 2 points. So if I draw a Mohr circle, then it will be like this. So this will be the center, and center will be, this total is 150 plus 50. So total is 200. This is the dia. So its radius will be here. So it is half of this dia. So it is 100, and this one also 100. So this is the radius, and if I rotate it, then this will be maximum shear stress. This will also be 100. This is radius, and this one is also Q max, maximum shear stress. This is 100. So maximum shear stress will be this one or this one. This is 100. So this is the right option. In the Mohr circle for strain, the radius of Mohr circle gives the minimum value of normal strain, maximum value of normal strain, maximum value of shear strain, half of the maximum value of shear strain. As we know, in case of Mohr circle for strain, this is my Ex, this is Ey, so this is gamma xy by 2. This is gamma xy by 2. So this will be maximum, gamma max by 2. So this ordinate in case of strain, this is half of the strain. So this one is the right option. For the plane stress situation shown in the diagram below, what is the maximum shear stress? So draw a Mohr circle. On this plane, this is tensile 20, and on this plane also it is tensile. So it means this point is same, and shear stress is 0. So neither it will go upward, neither it will go downward. So this itself is a point. This point itself is a Mohr circle. So maximum shear stress means this is 0 in this case. So, and this 0, there are two options when x and y axis are rotated 45 degree at all position of the orientation of x and y. This one is the right option because this itself is a point. So whatever rotation I will give, this itself will remain a point. So in all the direction, this value will remain 0. It means this one is the right option. In a piece of stressed material, the principal stresses are this. This is 3 kilonewton per meter square, and this one is compressive. So the line of action of the tensile stresses make an angle of 30 degree to the normal to the plane. What is the normal stress? Normal stress means, draw a Mohr circle for this. This is 3 tensile is the origin, and here it is compressive. It is 7. Means this is 7 compressive, this is 3. So this will be my Mohr circle, and 3 plus 7 is equal to 10. It means my center of this Mohr circle will be half of this. This is the dia, so it will be 5, and this will also be 5. So he wants to know this angle is 30 degree. 30 degree means this is the plane. So this angle is this is normal to this. So this will also be 30. So in case my theta is a negative, it is a clockwise rotations. So it means there is a clockwise rotations. So clockwise rotation means with the normal, with this plane, this is making theta 30 degree is a clockwise rotations. So this line will represents this plane. So from here it will be clockwise rotation of 2 times of this. So it will be 2 times of theta means 2 times of 30. So it is 60 degree. It means from the origin, this is the origin. So this component will give the normal stress. So this will be my P normal. So it will be equal to how much? So this distance is this is 5. This one is 5 from here to here, and since this is 7 from the origin, this one is 7 and this is 5. So it means this is 2. So this is 2. So horizontal projection of this will give this one. When I subtract this 2, that will give this one, and this is P normal. So P normal will be radius. Radius is 5. This is 5. This one is 5. This is also 5. So 5 cos 60 means 5 cos 60 is this one. From here to here, it is 5 cos 60. And this minus this 2 will give this one. And this is P normal. So cos 60 means 1 by 2 into 5 minus 2. So 2.5 minus 2 means 0.5. So 0.5, this one is the right option. A thin this is a thin wooden plate PQRS is made by gluing two pieces of wood along PR as shown in the figure. This is 45 degree, means this will also be 45 degree. So the value of sigma x is minus 30. So this is minus 30, means it is compressive. Sigma x is equal to minus 30. Sigma y is equal to 10. This one is 10. And tau xy is 0, means shear stress is 0. Then what is the normal stress on the surface PR? So this surface PR is this is the PR surface. So normal stress of this will be Pn, and this will be equal to, very easy, either I can calculate it analytically by putting simple in the formula. As we know, P normal is equal to P1 cos square theta sigma x cos square theta plus sigma y sin square theta. So simply I can find it. So this is minus 30 into cos square theta, means cos square 45 degree, plus this is 10 sin square 45 degree. So this minus 30 into this is 1 upon root 2. So square will be 1 by 2 plus 10 into 1 by 2 is 5, and it is 15. So it will be minus 10. So minus 10 is, this one is the right option. I can also find it by the Mohr circle. This one is minus 30. This is plus 10. And shear stress is 0. So this will be 30 plus 10. So total is 40. So this will be the center, and this will be the Mohr circle. So this is total 40 dia. So it means this is 20, and this one is also 20. So 45 degree means this plane is represented by this line, and from here 2 times of 45 degree means 2 theta is equal to 45 into 2 means 90. So here the 90 rotations. This will give the, at this is the point, at this from the origin, this is the origin. So this one from the origin, this will be the normal stress, and obviously it is on the left side, so it will be compressive. And what will be this? This total is, this is 20. So this is 20. And this distance is equal to as this is 30, we can calculate from this. This is 30, from here to here it is 30, and this one is 20. So this 30 minus 20 will be this one, and this is from the origin, this will be normal stress, which is minus 10. It is on the compressive side. So with this also we can calculate. In a plane strain condition in the xy plane, the strain components associated with the xy axis are this one. This is epsilon x, this is epsilon y. This is shear strain minus head random. What are the principal strain for these strain values? So this is 800, and this one is 400. This is 100, I think. This is 100. this is 100, and shear strain this is minus 400. Minus 400 means, so it will be half of this. So this will be half of this will be minus 400 into this. On this plane, this will be negative, means upwards. So it will be negative, and this is downward. So this is shear strain, and this is direct strain. Compressive on this side and tensile on this side. So this is 400. This will be half of this. This is half x by 2. So this will be 400, and this will also be 400. So this is my Mohr circle. So I have to know the principal strains for these strain values. Principal strain are obviously this one. This is the major principal strain, absolute one, and this one is the minor principal strain. And this is 800, means this 100. So this will be the center. It will be half of this. 800 plus 100 by 2. So this will be 450 into 10 raised to the power minus 6. So this plus this one will give the absolute 1. So absolute plus 1 plus this is this plus this one, and this is equal to this one is equal to, it is nothing but the radius. This is the radius. So this radius means this will be 800 minus 100 means 700. So this will be 350, half of this. So 800 minus 100 means 700 divided by 2. So this will be 350, and this is 400. So it means this radius is equal to 400 square plus 350 square root. So absolute 1 will be, this is 450 plus this one radius, this plus this is radius, and this is equal to this one, and this is equal to 450 square, no, 400 square plus 350 square. So 10 square I can take common, so it will be 10. So it will be 40 square plus 35 square. So 450 plus 10, and this will be 1600 plus 35 square means so it is, so this will be 2825 root into 10, and this will be so root of this will be Mm, 45 means 50. So it will be 54 something. So 540 plus 450 means 900 something. So this one, this will be the correct answer. This is the principal strain, major principal strain, and minor will be so this will be approximately 450 minus 540 means minus 90 approximately. So this one will be the answer. So calculation part you people can do. In a plane strain case, in the xy plane, normal strain in the x and y directions are equal to 0 and shear strain is equal to this one. The Mohr circle, if I draw a Mohr circle, then normal strain is the strain in the x and y direction, normal strain is 0 means this is the origin, and shear strain is equal to this one. This is phi xy is equal to 3 into, and in case of Mohr circle, half of this will be the ordinate. So this will be phi xy by 2. So this is 1.5 into 10 raised to the power minus 6, and here also it will be same. So this will be my Mohr circle. So what is the diameter of the Mohr circle? So dia of this will be 2 times of this. So 2 times of this will be 3 into this one. So this will be the dia of the Mohr circle. So this is the right option. For a case of plane strain, sigma x, sigma y is equal to 0, and this is what are the principal stresses and their orientation with x and y axis. So this is 40, this is 40, and no stress here. Tau xy is 80. This is also 80. Let us draw a Mohr circle for this. This is 40, and on this plane it is 0. And on this plane, this is represent this plane, and shear stress is plus 80. Since it is anti-clockwise rotation, so plus will be downward. So it is 80, and on this plane also this will be 80. So this will be my Mohr circle, and principal stress will be from this origin. So this is sigma 1 from the origin, and this will be sigma 2. This sigma 1 is equal to how much? This is 0, this is 40. So this will be half of this. This is 20 plus 20. So this sigma 1 will be equal to this 20 plus this one, and this is equal to this one, and this is equal to the radius of the Mohr circle, and this is 20, this is 80. So 20 square plus 80 square root, I will get this one. 20 square plus 80 square, I will get this one. This is equal to this one. This is the radius, and this plus this 20, I will get measure principal stress. And So this is equal to this 10 square I can take common. So it will be 4 plus 64 plus 20. So 4 plus, which is 10 into 68 plus 20, and root of 68, it will be this will be 20 root 70, means it will be something 4, it will be 80 something plus this 20, so it will be 100 plus. So 100 plus means this one. So this will be 100.25, 102.5, and this one will be, this one will be the, this is the radius, this is the radius, radius will be equal to 100, this will be something 80 plus and minus this 20, so it will be 62.5. So this one is the right answer. A thin rod of 10 mm diameter is subjected to a tensile force of this one. What are the principal stresses and maximum shear stress? The rod, and there is a load of 7850 Newton. So stress divided by the area. Area is pi by 4 into 10 square. So this will be the stress. So maximum shear stress will be equal to how much? In this case, maximum shear stress will be on this plane, which is 45 degree, and this value will be half of this one. Otherwise, for Mohr circle also, this one is sigma x, shear stress is 0. So at this plane, this is 45, this is 90. So here my shear stress is maximum, and this will be equal to the radius of the Mohr circle, which is 5 by 2, sigma x upon 2. So half of this will give the maximum shear stress. So 1 by 2 into this one. So principal stresses will itself be this one. This itself will be the principal stresses. because shear stress is 0 here, and maximum shear stress will be this one. So this will be approximately 50. So this is 50. This one is 50, and obviously the maximum principal stress, this will be 2 times of this one, means this is 50, this is 100, and the maximum shear stress, principal stresses and maximum shear stress. Why are, yes, yes, principal stress is on this plane, on the other plane it is 0. So answer will be this one. So sigma 1 is equal to this, it will be this one. Sigma 2 is 0 here, and maximum shear stress is half of this. This is 50. So this one is the right option. If sigma x, sigma y, and tau xy are normal and shear stresses on the x and y faces, what is the radius of the Mohr circle in terms of these stress? Yes, radius of Mohr circle is, this is sigma x, sigma y, tau xy. So if I draw a Mohr circle, then it will be, this is sigma x, sigma y, this one is tau xy, this is tau xy. So this is my Mohr circle. So radius will be this one. So this is sigma x, this is sigma y. So this will be sigma x minus sigma y, and this one will be the half of this. So it means this is sigma x minus sigma y by 2, and this is tau xy. So this square plus this square is equal to this square. So this radius is equal to root of square of this one plus tau xy square. It means this one is the right option. So there is assertion and reason. A plane stress system consists of two principal stresses sigma 1, sigma y, and a plane strain system consists of two principal strains epsilon 1 and epsilon y. Both the system are identical. We cannot say identical because strain can exist in the third directions, whereas stress, this is a two-dimensional sigma 1 and sigma 2 is there, so sigma 3 is 0. But in case of strain, in the third direction strain will be there, so both are not identical. So this one is false. So A is false means this one is the right option. At a certain point in the structural member, there are perpendicular stresses 80. This is 80, and this one is 20. Both are tensile. What is the equivalent stress in simple tension according to the maximum principal strain theory? What principal strain theory says that sigma 1 upon E minus 1 upon M into sigma 2 is equal to Fy upon E. So this is direct strain yield stress divided by this. It means sigma 1 minus 1 upon M into sigma 2 is equal to Fy. Sigma, this is 80, Poisson ratio is 0.25 into sigma 2 is 20. So it means, so equivalent stress in simple tension will be this one, So this is 80 minus 50. So no, this will be this will be 5. So 80 minus 5 is equal to 75. So this one is the right option. In a plane strain problem in the xy plane, this shear strain is this normal strain in xy direction is 0. So let us draw more. The absolute ex and ey is 0, means this is the origin. So this is 0 here, and shear strain is equal to this one. So this ordinate is half of the shear strain. So this will be half of this one. So this is 6 into 10 raised to the power minus 6 on this plane. On the other plane, it is also equal to this is. For this state of strain, what is the diameter of the Mohr circle? So obviously, the dia will be this plus this. This is 6 plus 6 is equal to 12 into 10 raised to the power minus 6. So this one is the right option. At a certain point in a strained material, there are two mutually perpendicular stresses. This is this. This one is 100. Both are tens. This is 100. And this one is compressive. Tension is positive, compression negative. What are the values of the principal stresses at this point? So obviously, as no shear stress is acting on these faces, so these stresses itself are nothing but principal stresses. So principal stresses means sigma 1 is plus 100 and sigma 2 is equal to minus 50. Though these stresses itself are principal stresses. So this one is the right option. For a state of plane stresses, sigma 1 is equal to sigma x is equal to this. What are the value of the maximum in plane shearing stress and absolute maximum shear stresses? So these are the principal stresses. 40. This is 20. So let us draw a Mohr circle for this. It will be like this. This is the origin. So this is 40. And this one is 20. Means this will be the Mohr circle. And value of the in plane shearing stresses, maximum shear stress will be this one. And this 40 minus 20 means 20. So this is 20 is the dia. So radius will be 10. This is 10, 10, and this will also be shear. So maximum shear stress will be this one. This is plus 10 and this is minus 10. So it will be plus minus 10. And absolute maximum shear stress means absolute, in case of absolute it will be 10 plus 10, it will be 20. So this one will be the right option. So these are certain reason. The following items consist of two statements. Oh, let us see this. A rectangular element is subjected to pure shear. This is a rectangle element, and there is a pure shear, means no normal stress. This is a case of pure shear. This will result in cracks along the one diagonal and crushing along the other diagonal. Yes, as we have explained. So there will be cracking. There will be tensile on this plane, and the value will be same. So these are my principal stresses, and on it will be compressive like this. On this plane it is compressive, and along this plane it is so along this plane it is compressive, and along this plane it is tensile. So cracking will be like this. Pure shear on a rectangular element results in tension along the one diagonal and compression along the other diagonal. Yes, both are true, and this is the correct explanation of A. So answer is first option. This one is the right option for this. For a ductile material, the maximum shear distribution theory is, for a ductile material, the maximum shear stress distribution theory is most suitable. Why? The maximum shear distribution theory of failure assumes that yielding can occur in a general three-dimensional state of stress. So shear distribution theory assumes that yielding can occur in a general three-dimensional state of stress. So the answer is B. Both are correct, but this is not the correct explanation. The Mohr circle given below corresponds to which one of the following? So this is a case of so this Mohr circle represents, this is a Mohr circle of which one figure out of this? So obviously this is a case of pure shear. In case of pure shear, for this case, if I want to draw the Mohr circle, it will be like this. On this plane it is negative, it is 1000 MPa. This is my shear stress, negative, and it is positive, and here the direct stress is. On this plane it is, so it is negative on this plane, means here it is 1, and on this plane it is positive, and normal stress is 0 here. So if I draw a Mohr circle, it will be like this. This is the radius 1000 MPa. So this will also be 1000. This will also be 1000. So it means this is a case of pure shear. Means this one, and it means C is the right option. In a two-dimensional stress system, the principal stresses are this 180, so let us draw a Mohr circle. This is 180 P1 tensile, and P2 which is compressive. It means this is P2, so compressive will be on this side. For the material yield stress in simple tension and compression, and Poisson ratio is this one. According to the maximum normal strain, for what values of P2 shell yielding will commence? So it is case of normal strain theory, means maximum principal strain theory. What maximum principal stress theory says? Sigma 1 minus this will be 1 upon m sigma 2 is equal to Fy. Sigma 1 is equal to 180 and this is sigma 2 means P2. This is compressive, so it will be minus P2 into 0.25 is equal to 240. So it will be 180 plus P2 by 4 is equal to 240. So it will be P2 is 240 minus 80. 60 into 4 is 240. But if I take absolute like this, P2 minus 1 upon m sigma 1 is equal to 240. Since this 240 is in compression also. So in this case, it will be sigma 1 is equal to this will be minus, if I take compressive, and this will be oh no, this will be minus P2 minus 180 is equal to 240. This is 240. In case of simple, it is if I take in compression, so this will be, suppose I have take compression as positive, so this P2 and this is tensile. So tensile means effect will be negative of the compression. So it will be minus 180 into 1 upon m is equal to 240. So this P2 plus 180 into 0.25 is equal to 240. So P2 will be 240 minus this one, and this will be 195. So 194. But if I take P1 minus in this case it will be P1. So effect will be, if I take this tensile and this is compressive, so it will be this is 180 plus P2 into 0.25 is equal to 240. It will be 240 in this case. So I will take lesser of the two, means 192. So in this case it will fail in compression. First of all, it will fail in compression. So this one is the right option. If the maximum principal stress for an element under a biaxial stress situation is this one. So maximum shear stress is also 100. Then what will the other principal stress? If the maximum principal stress for an element under biaxial stress situation is 100 tensile and the maximum shear stress is 100 MPa, then what is the other principal stress? Suppose this is sigma 2, this is sigma 2. So if I draw a Mohr circle, then this is 100 and biaxial means no shear stress. So this one is sigma 2. So if I draw a Mohr circle, it will be like this. So this will be 100 minus sigma 2 and half of this will be this one. So this will be half of this one and this is equal to this also, which is maximum shear stress. This will be the maximum shear stress and this maximum shear stress is equal to this radius is equal to half of this. So 100 minus sigma 2 divided by 2 will be the radius, means maximum shear stress. This is 100. It means sigma 2 is equal to 100 minus sigma 2 is equal to 200. So sigma 2 sigma 2 will be 100 minus 200 means minus 100. Minus 100 means compressive. So minus 100 compressive means this one. So this C is the right option. According to maximum shear stress criteria, at what ratio of the maximum shear stress to yield stress of material does the yielding of material takes place? So maximum shear stress theory, what maximum shear stress theory is my Q max will be sigma 1 minus sigma 2 by 2. When this maximum shear stress, this is maximum shear stress, this becomes equal to the shear stress due to yielding in case of a simple test, that will be Fy upon 2. So maximum stress will be Fy by 2. So the maximum shear stress ratio of the maximum shear stress to yield stress. So this Q max upon this Fy will be equal to 1 by 2. It means this one is the ratio. So this is the correct option. If P1 and P2 are the principal stress at a point in a strained material, then with so what is the principal strain? So principal strain, obviously this is P1, both are tensile means, so principal strain in this direction is equal to P1 upon E minus 1 upon M Poisson ratio into P2 upon E. So this is the formula, means P1. So it means this one is the right option. An element is subject to stress as given below. For this state of stress, what is the maximum shear stress? So let's draw Mohr circle. This is 20 here and this is 10. So half of this will be 20 minus 10. So this will be the dia of the Mohr circle, and its radius will be half of this, means 5. This one is also 5. So maximum shear stress will be, obviously this is Q max, so it is equal to 5. So 5 is the right option. So Mohr stress circle helps in determining which of the following: normal stresses on one plane, normal and tangential stresses on two plane, principal stresses in all the directions, and inclination of the principal planes. And the option is either 1 or 2, 2 and 3, 3 and 4, 2 and 4. These are the correct answer. But there is some mistake in the question itself. All these things can be found with the help of the Mohr circle. So all the options are correct. Consider the following statement: Mohr circle strain circle can be drawn for plane stress. So Mohr strain circle means, so which of the statement are correct? So Mohr circle of strain means it will be for, not for plane stress condition, it is always for strain. Strain in the 3 direction are known. Yes. If the strain on 2 mutually perpendicular which of the above statement are correct? So this 2 and 3, this one is the right option. What is the angle between the principal strain axis and the maximum shear stress? Yes, this is the Mohr circle. Suppose this is P1, this is P2, and this is Q something, this is Q. So what is the angle between the principal strain axis and maximum strain axis? So this will be epsilon 2, epsilon 1. So principal strain axis means this one. This is the epsilon 1, epsilon 2. So this will represent the principal strain axis, and this is the maximum strain axis. Maximum strain axis. This is phi max by 2. This is maximum strain axis. This is maximum principal strain axis. So angle between these is 2 times of theta. So this is 2 theta means it is 90. So theta is equal to 45 degree, means this one is the right option. In a strained material, the principal stresses in the x and y directions are this. On an inclined plane, the normal to which make an angle 30 with the axis, what is the tangential stress? So this is the case. This is 100. This is 30. Oh, no, 60. Compressive. On an inclined plane, the normal to which, this is the inclined plane, normal to this makes an angle of 30 with the x-axis. This is 30 degree. It means this angle is also 30 degree. So what is the tangential stress in? These are the principal stress, means no shear stress is acting. So let's draw a Mohr circle. This one is 100. This is 60 here. And no shear stress means this is 160. So half of this will be 80, 80. So this will be the center of the Mohr circle, and this will be 80 and 80. So if I draw, this will be the Mohr circle, and angle of 30 degree to the x-axis is the plane. On an inclined plane, the normal to which make an angle 30 degree means this is the plane. So rotation is identical wise, this is theta 30, so means I will rotate 60 degree. So this from the origin, this will give a normal stress. So obviously this is 80, 80, 80 is the radius. If this is 80, this is also equal to 80. Okay. So this will be 80 cos 60. 80 cos 60 means 40. So this one is 40. And how much this is? Since this is 80 and this one is 60, so it will be 20. So this 40 plus 20, this will be the normal stairs 60. It means this one is the right option. At what value of the ultimate shear strength shall the material under the action of uniform axial tension fails due to shear? At what value of the ultimate shear strength shall the material under the action of uniform axial strength? So in this case, if this is P, then obviously at what value of the ultimate shear strength shall the material under the action of a uniform, yes, so obviously it will be half of this one. So maximum shear will be on this plane and this will be equal to half of this one. So otherwise also according to maximum strain stress theory, Q max is equal to sigma 1 minus sigma 2 by 2. So sigma 2 is 0 here. So it is sigma 1 by 2 means this P bar by 2. So it will be half of the ultimate tensile strength. At what is the diameter of the Mohr circle in this case? Yes, this is 10 tensile, and on this plane also this is 10 tensile, means this point is same, and shear stress is 0 on this plane, means it is neither it will go upward nor it will go downward. So this itself is a point, this point itself is a Mohr circle. So diameter of this Mohr circle, obviously it is just a point, so it will be 0. So this one is the right option. In a plane strain situation in the xy plane, these displacement at a point are given by this is u and this is v. What is the shearing strain? The formula for the shearing strain is shearing strain phi xy is equal to delta u upon delta y plus delta v upon delta x. So this is u, this is v. So slope of this with respect to y, to delta u with respect to y, and delta v with respect to delta x. So this is delta v upon delta x. So this is will give you shear strain. So delta u upon delta y is equal to, so it will be delta u upon delta y, it will be 8, and delta v upon delta x is equal to -3. So it will be 5 into this one, means this one is the right option. If a body carries two unlike principal stresses, what is the maximum shear stresses? Two unlike. If a body carries two unlike principal stresses, what is the maximum shear stresses? Half the difference of the magnitude of the principal stresses, half the sum of this. So obviously, if this is sigma 1, this is sigma 2, and in case of Mohr circle, this is sigma 1, this is sigma 2, and this is the maximum shear stress, which will be equal to the radius. Radius is equal to sigma 1 minus sigma 2 divided by 2. So this is 1 by 2 of the, yes, and these are two unlike. Unlike means if this is tensile, this will be compressive. So when they are unlike, so it will be sigma 1 minus sigma 2 by 2 means sigma 1 plus sigma 2 by 2. So it will be 1 by 2 of the sum of the two. So this one is the half of the sum of the magnitude of principal. So this is unlike, means one is negative tensile, other is compressive. So it will become sigma 1 plus sigma 2 by 2. In a biaxial strain system, epsilon x and epsilon y, what is the maximum engineering shearing strain? So obviously, this is epsilon x, epsilon y. So this will be epsilon x minus sigma y, and this is my Mohr circle. So maximum shear strain, this is the radius, it will be epsilon ix minus ey by 2, and this represent shearing strain phi xy by 2. It means phi xy by 2 is equal to epsilon x minus epsilon y by 2, means shearing strain is equal to this one. So this is the right option. In a tensile test on a cast iron specimen, the failure of the specimen is on a cross section perpendicular to the axis of the specimen. In a tensile test on a cast iron specimen, the failure of the specimen is on a cross section perpendicular to the axis of the specimen. The failure of the specimen is on a plane subjected to maximum tensile stress, and cast iron is relative weak in tension. Yes, cast iron is a brittle metal. In case of brittle metal, it will show like this. So failure will be along the cross section. So means A is the right option. In a tensile test on a mild steel, in a mild steel, this failure of the specimen is along a plane at 45 degrees to the cross section. Yes, the failure of the specimen is on a plane subjected to maximum shear stress, and mild steel is relative weak in shear. Yes, in case of ductile metal, the failure will be along this one, which is 45 degrees. So it means option A is the right one. What would be the shape of the failure surface of a standard cast iron specimen subjected to torque? So if it is a cast iron metal and there is a torsion, then failure surface would be cup and cone shape. plane surface perpendicular to the axis of the specimen, pyramid type wedge shaped surface perpendicular, or helicoidal surface at 45 degree to the axis of the specimen. So it will be helicoidal. At a point in a piece of stressed material, these stresses are sigma x is equal to this one, sigma tau xy is equal to this one. Although the value of the alpha and beta are not known, yet the principal stresses are equal to each other, being this one. What is the radius of the Mohr circle? So sigma x is equal to, this is sigma x and this is alpha, and tau xy is beta. So this is beta. So although the value of the alpha and beta are not known, yet the principal stresses are equal to each other, being 5 kilonewton. What is the radius of the Mohr circle? In this question, what he says that the principal stresses are equal to each other. What does it mean? If this is a principal stress on one plane, this is sigma and this also is sigma. So this point represent both the planes, and obviously at principal stress is shear stress is 0. It means this itself is a point and this itself is a Mohr circle, so radius is equal to 0. So this one is the right option. What is the radius of Mohr circle in case of biaxial state of stress? Half the sum of the two principal stresses, half the difference of the two principal stresses, difference of the two principal stresses, sum of the two principal stresses. Obviously, this is sigma 1, so this is sigma 1, this is sigma 2, so this will be sigma 1 minus sigma 2, and half of this will be the radius, sigma 1 minus sigma 2 by 2. So this radius is equal to half of this. The radius of so half is the difference of two principal stresses. This one is the right option. Figure below shows a state of plane stress. This is sigma x and shear stress is negative, means upward. So this one is 56. I will get this point. And sigma y is 21. It is 21. So, and this will be 56. So this will be my Mohr circle. So minimum principal stress is oh no, minimum. In this case, the minimum principal stress is -7, means compressive. It means Mohr circle will be something like this one. So this will be my minor principal stress, which is 7 compressive. Means this is 7. This is the origin, and obviously this will be the center of the Mohr circle. So this obviously this will be, this is sigma x, and this is 21. So this will be sigma x minus 21. So this will be sigma x minus 21 by 2, sigma x minus 21 by 2. So I have to find the sigma x. So obviously this from here to here, although to the scale it doesn't appear. So from origin to this, from here to here, this will be the radius of the Mohr circle. This will be the radius of the Mohr circle. The radius of the Mohr circle will be how much? It will be this square plus this square. So radius will be sigma x minus 21 by 2 whole square plus this square plus this square. This is 56 root of this. I will get radius. So this will be the radius, and this radius will also be equal to this much. This much. So this much minus this whole is how much it is? Minus 7. So this radius is equal to, this is my radius, this minus this 7. So this minus 7, this is the radius. So this whole is the radius, this radius minus this is 28. So this radius minus this 28, I will get this one, and this is equal to this one. So this is the radius minus 28. I will get sigma x minus 21 by 2. It means this will be sigma x minus 21 by 2 plus 28 is equal to this one. If I square both the side, then it will be sigma x minus 21 by 2 whole square plus 56 square is equal to sigma x minus 21 by 2 square plus 28 square plus 2 times of this one. So this one and this one will cancel each other. So 56 square minus 28 square is equal to, I will get, this will be 56 square minus 28 square is equal to sigma x minus 21 by 2. So 56 minus 28 means 56. A square minus b square means A plus B minus A minus B is equal to sigma x minus 21 by 2. So it will be 28. So 28 will be here also. So this 28 and this 28 will be cancel each other. So this will be 84 into 2 is equal to sigma x minus 21. So this will be 168 plus 21 is equal to sigma x. Let us see how the answer is. Oh, what is, I think some mistake is there. There is some mistake. Oh. So this 2 and 2 will cancel each other. So this will be not be there. It will be 84. So 84 plus 21 means 105. It means this 105 is the right answer. The details of principal stresses at a certain point in a steel member are this. Major principal stress is this. Minor principal stress is this. The uniaxial tensile yield stress is this one. According to the maximum shear stress theory, what would be the value of the sigma 2 in Newton per mm square at which the yielding will commence? 120 tension, 90, 80, which one? So as per maximum stress theory, what it says that this sigma 1 minus 180 into mu oh, no, this is maximum stress theory. Shear stress theory is sigma 1 minus sigma 2 by 2 is equal to Fy by 2. So sigma 1 minus sigma 2 by 2, how much it will be? It will be 180 minus sigma 2 is equal to Fy. Fy is equal to 240. So, oh, it is tensile, it is compressive. So, compressive, in case of compressive, it will be this one. So, sigma 2 is equal to 60 here. It means sigma 2 is equal to 60. So, this one is the correct answer. Element of structure is subjected to principal sigma 1, sigma 2 yield stress both in simple tension and compression of the metal is this one. Question is, what is the value of the sigma 2 in Newton as per maximum normal strain theory? Maximum principal strain theory means sigma 1 minus sigma 2 upon m is equal to Fy. So this is the formula. So E and V will cancel. So sigma 1 is 200 minus this is compressive. So it will be minus sigma 2 into 1 upon this Poisson ratio is equal to 240. So it means this will be sigma 2 into 1 by 4 is equal to 40. Sigma 2 is equal to 160. So this one is the right option. A two-dimensional stress system has like stresses sigma x is equal to this and sigma y is equal to this in two mutually perpendicular directions. Then xy coordinate of the center of the Mohr circle will be how much? This is the origin. Sigma x is equal to 100 and this is also tensile. So it means this is 200. So this will be the Mohr circle. So this dia is 200 minus 100. So it is 100. And coordinate of this will be, so this will be obviously, this is 100 plus this is half of this. So this is 50. So coordinate of this center will be 150 is the x coordinate and y coordinate is 0. Obviously shear stress is 0. So 150 in 0. This is the coordinate of the center of the Mohr circle. The limit of proportionality in the material of the structure is steel member when subjected to simple tension is this one. The principal stresses in the material is sigma 1 is equal to this one tensile and this is compressive. This is the Poisson ratio. According to maximum strain theory means sigma 1 minus sigma 2 upon m is equal to Fy. So sigma 1 is equal to 122 and this is compressive. This is 60 means into Poisson ratio is 0.3. How much it will be? This is 122 plus 18. So it will be 140. So this 140 and this is 280. So factor of safety will be this upon this. So 280 upon 140 is equal to 2. So this is the value of the factor of safety. A square element is subjected to principal stresses like this. The intensity of normal stress, this sigma n is equal to, so this is tensile 200 and this is compressive 200 and shear stress is obviously 0. So this one will be the Mohr circle. So normal stress as theta, this theta is how much? Since this is a square element, means this theta, this, if this is the theta, this is theta, this is 45 degree. So normal strain will be 2 times of theta. It means 2 times of theta will be obviously 2 into 45, this will be 90 degree. So at this point, what is the normal stress? This is the original. So normal stress, this Pn is equal to 0 here. This is the origin. Normal stress is 0. So this one is the right option. Principles. Consider the following statement. If there is a state of pure shear at a point, then Mohr circle is tangential to the axis. Center of the Mohr circle coincide with the origin. Unlike principal stresses are each numerical equal to tau and principal stresses are like. So obviously in case of Mohr, suppose this is the pure shear case, this is tau, so Mohr circle will be like this. This is the origin. So normal stress is 0 here. This is positive means tau. On this plane it is negative clockwise rotations. So my Mohr circle will be, this will be the radius. So this will be the Mohr circle. And the center of the circle will coincide with the origin. Number 1, this Mohr circle is tangential, this is wrong. Center of the Mohr circle coincide with the origin. Unlike principal stresses is this one and this one. This major principal, this will also be equal to this radius tau. This is tensile and this is compressive. So they, unlike principal stresses, one is compressive, other is tensile. So 2 and 3 is the right option. Principal stresses are low. This is wrong. So 2 and 3 means this is the right option. At a point in two-dimensional stress state subjected to biaxial stress, what is the normal stress acting on plane AB? So let us draw a Mohr circle. This is the origin. This is sigma. On this plane also, this is sigma tensile. This is sigma tensile, and shear stress is 0. So normal stress, how much normal stress will be on this plane? As on this plane it is sigma, and on this plane also it is sigma. So my Mohr circle will just be a point. It is simply a point. So it means my normal stress will also be equal to 0, as this itself point is a Mohr circle. So everything is a 0. Which of the following theories of failure most appropriate for a brittle material? In case of brittle failure, the most stable theory is maximum principal stress theory, Rankine theory. So this is the right option. In a strained material, the principal stresses in x and y directions are 100 Newton and this is 60. Compressed on an inclined plane, the normal to which make an angle of 30 to the axis of measure principal stress. How much? Let's draw a Mohr circle. This is 100 tensile and this is 60 compressive. So these are principal, means shear stress is 0. So this is my Mohr circle. This total is 100 plus 60, 160. This is the dia of the Mohr circle. So half of this will be the radius. This is the center of the Mohr circle. So this will be half of this, 80 plus 80. So how much principal stress will be? I have to know. On an inclined plane, the normal to which, so theta in this case is 30 degree. So it means it will be 2 times of theta, 60 degree rotation. So this point I will get. So I have to know the normal stress. So normal stress, this is from the origin. This will be Pn normal, which I have to calculate. This Pn is equal to how much? So this is, as this, the radius is 80 and this is 60. So this will be 80 minus 60, 20. This 20 plus this horizontal projection of this one. This is the horizontal projection of this plus this 20 will give Pn normal. So normal will be 20 plus horizontal projection. So horizontal projection how will be? This is the radius which is equal to 80. So 80 into cos of this angle, which is 60, will give the horizontal projection, this one. So this will give normal stress. This is obviously 1 by 2, 40. So 40 plus 20 is equal to 60. So this one is the right option. Which of the following statement is correct? Principal stress is defined as the shear stress on plane on which normal stress is maximum. This is wrong. The center of the Mohr circle for a two-dimensional stress system always lies in the xy, in the y axis, adopting conventional axis notations. This is also wrong. The plane of maximum shear stress is inclined to the plane of maximum principal stress. Yes. So in case of Mohr circle, as we know, maximum stress suppose as we know this is sigma 1, sigma 2, no shear stress if suppose it's act on there. So this will be the Mohr circle. So this will be the plane of maximum shear stress. This is Q max, and this is the maximum shear stress plane. This is maximum principal stress plane. Principal stress plane. So angle between this is 90 degree. It means this is 2 theta. So theta will be 90 upon 2 is 45 degree. So plane of maximum shear stress is inclined, and the plane of the principal stress, this will be 45 degree. On this plane my shear stress will be maximum. So this is the right option. Match list 1 and 2 and select the correct answer. So this C is a case of pure shear. This is a case of pure shear. So pure shear means this is a case of pure shear. So 3 will connect this C. So with C it will be 3, and this is a case of uniaxial test. So Mohr circle will be like this. This is P and this is 0 here. Shear stress is 0. So my Mohr circle will be like this. This will be P by 2. So 2 will be this one. So with A it will be 2. So C3 and A2. C3 so with C it is not 3, it is either 1 or 4. So means this 1 is not possible. This can be a case of pure shear. So C it will be 4. These are approximately. So with C it will be 4, and so C will be 4 and this A will be 2. So C3 A2, C4 A2. C4 A2 means C4 A2. It means this one is the right options. No, C3 C4 A2. So C4 A2 means this one. This C is the right option, and with B it will be 1. So 1 is this, and B so obviously in this case there will be a shear stresses. So shear stresses will be there in this case. So it will be this one. So C4 and B3, C for B3 means, so this one is the right option. In a two-dimensional stress system, the radius of the Mohr circle represents what? It is a maximum shear stress. As we know, this is the Mohr circle. So this radius, this is the radius, it represents maximum shear stress. So this is the right option. In a plane strain problem, there are normal tensile stresses, this one, and so this sigma x, this is sigma y. Sigma x is greater than this. This is sigma x, this is sigma y, and this is tau xy. So Mohr circle will be this one. This is sigma x, sigma y, tau xy, tau xy. So this will be the Mohr circle. So it is observed that the minimum principal stress means this one. This is a sigma 2, and this will be equal to how much? This will be equal to, so this will be obviously minimum principal stress on a plane is 0. So if this sigma 2 is 0, means it will be like this. So it means so this minimum principal stress is how much? It will be equal to radius. So radius is equal to sigma x minus sigma y by 2, this one, and this is tau. So radius will be sigma x minus sigma y by 2 square plus tau xy square root. So this will be the radius, and this will be equal to this one, minimum principal stress on a plane. As we know, formula for minimum principal stress is sigma x by 2 minus sigma x minus sigma y by 2 square plus tau xy square. So this will be 0. It means this is equal to this. So square of this is equal to square of this. So it is sigma x plus sigma y by 2 whole square is equal to sigma x minus sigma y by 2 whole square plus tau xy square. It means it will be sigma x plus sigma y square plus 4 tau xy, and this will be 2 sigma x sigma y. So 4 sigma x sigma y is equal to 4 tau xy. So tau xy is equal to root of this one, means this one is the correct option. Steel has proportional limit of 300 MPa in simple tension. It is subjected to principal stresses of 120 and 60 tensile and 30 compressive. There are 3 principal stresses in this case. What is the factor of the safety according to maximum shear stress theory? So what maximum shear stress theory means? This will be 120 minus this 30. This is compressive, this is tensile. So it will be this by 2. This will be maximum shear stress, and this will be 75, and this is the elastic limits. So this equal to 300 by 2 means 150. So this divided by this will be 2. So 2 will be the factor of safety. According to maximum shear stress, failure yielding occurs in the material when maximum shear stress is equal to yield stress. Maximum shear stress is equal to 2 times of yield stress, or maximum shear stress is equal to 1 by 2 of yield stress. This one is as per maximum shear stress theory, sigma 1 minus sigma 2 upon 2. This is Q max. This becomes equal to Fy by 2, means Q max is equal to Fy by 2. So this is half of the yield stress. So this one is the correct option. For the design of cast iron member, the most appropriate theory is, as the cast iron is brittle material, so obviously it will be maximum principal theory or Rankine theory. So this is the right option. The principal stresses are like this. The intensity of normal stress on oblique plane BE. This is the plane BE. So normal, this normal I have to calculate. If this is 30, this will be 30. Let us draw a Mohr circle for this. This is 400. This one is 100. And no shear stresses. Oh, this is compressive. So this compressive means this is 100 here, this is 100, and this is 400. So total will be 400 plus 100, so it will be 500. So this 500 will be the dia of the Mohr circle. So half of this will be 250 each. So this will be the radius, and this will be my Mohr circle. So what he wants to know, the intensity of normal stress 30 degree with the so on this plane my theta is, there is a anti-clockwise rotations, means from here it will be 2 times of theta, means it is 60 degree here. So this one is 2 times of theta, 60 degree. So normal stress I have to find. Normal stress will be, this is my origin. So from this point to this is the normal stress, and this will be equal to how much? Since this is 250 and this one is 100, so obviously it will be, this is 150, 200 minus 250 minus 100. So this will be 150 plus horizontal projection of this one. So horizontal projection will be how much? This is the radius. So 150 plus horizontal projection of this radius, which is 250, into cos of 60 degree. So 150 plus 250 into cos of 60 is equal to 1 by 2. So this will be 275. But 275 is not there in the option. So there is some mistake. It might be 275. Then we can say C is the correct answer. Otherwise, there is a problem. A mild steel bar of square cross section had a sectional area of this. It is subjected to axial load force of 20 kN. The intensity of normal stress in Newton on an oblique plane at 45 degree with the y-axis, which is normal to the longitudinal axis, will be how much? This obviously will be half of this one. As we know, at 45 degree it will be, this is a clockwise, so normal strain. So 20 kilonewton divided by cross section area. So this will be 100 Newton mm square. If I draw a Mohr circle, it will be 100 here. On this plane it is 0. It will be my Mohr circle, and there is a 90 degree clockwise rotation from this plane. So it will be here. So at this point, my normal stress will obviously be equal to, this is the half of this is 50. So this 50 is the answer. The rectangular bar of cross section area A is subject to the external tensile load P. The maximum shear stress will occur on a plane to any normal section where this is how much. So as we know, this is same case. This is a P load. So stress will be P upon A. If I draw a Mohr circle, then it will be P. On this, it is 0. This will be my Mohr circle, and its radius will be, this will be half of this P by 2. This will be half of P by 2. What he want to know? The maximum shear stress. This will be the Q max. So maximum shear stress, what is this angle? This is 90, and this 90 is what? This is 2 theta, means theta is equal to 45 degree. So this theta is equal to 45 degree. So this one is the right option. Which of the following statement are correct? Experiment results in a thin walled tubes show that maximum normal stress theory is valid. Normal stress theory is valid in case of brittle metal. Yes. Principal stress theory is valid in case of brittle metal. In case of pure shear, Saint-Vinant theory is more valid than other theories. This theory is, I think, this 3 is not correct. So in case of pure shear, my maximum principle Saint-Vinant theory, what it says, that failure will occur at 0.5. So Saint-Vinant theory is maximum shear stress theory, and this, in case of simple test, it will be 0.5 times of Fy, but material will fail somewhere 0.577 Fy. So is wrong. Tresca theory is very closely to substand by experimental results. Yes. In maximum stress theory, the yield locus is hexagonal. Is wrong. So 2 and 4, this 3 will not be there. So 3, this, and it will be 1, 2 and 4. This is also, so 1 to 4 is the right option, means this is the right option. Statement: the most suited failure theory for concrete is maximum when? Most suited failure theory for concrete is maximum shear strain theory. Ductile materials are limited by their shear strength. Both statements are correct. This is a most suited failure theory for concrete is a brittle metal. Concrete is a brittle metal, and for brittle metal it is Rankine theory, not maximum shear stress theory. It is the maximum principle theory which is suited. So this one is false. So ductile materials are limited by the shear strength, obviously. Okay. So this A is false, means this D is the right option. Consider the following statement: if the planes at right angles carry only shear stresses of magnitude Q in a certain instance, then obviously it is a case of pure shear, like this. So in case of pure shear, my Mohr circle will be also like this. So this will be my Mohr circle. So only shear stress, diameter of the Mohr circle would be equal to, yes, this will be Q plus Q, it is 2Q. Center of the Mohr circle would be at the origin, yes. The principal stresses are unlike and are of magnitude Q each other, yes. This is also equal to radius Q, this is tensile, this is compressive, this is also okay. The angle between the principal plane and the plane of maximum shear would be 45 degrees. Since this is maximum shear and this is maximum plane, so this 90 means theta is equal to, this is 2 theta, 45 degree. So this one is also correct. It means 1, 2, 4, 3, 4 all are correct. Means this one is the right option. The state of two-dimensional stresses acting on a concrete lamina consists of direct tensile stress, this one. When cracking of tensile is just about, the permissible tensile strength of concrete is how much? Let's draw a Mohr circle. Sigma x is equal to 1,5, and this is a direct tensile case. So on this plane it is 0 here. Shear stress is 1.2. So this is 1.2. This one is also 1.2. So this will be my Mohr circle. So when cracking of concrete is just impending, the permissible tensile strength of the concrete will be how much? This is the maximum principal stress, sigma 1. And this will be equal to how much? This will be half of this one. It is 0.75. 0.75 here. So this principal stress will be equal to this one, 7.75 plus this one. And this is equal to this. This is the radius plus radius. Radius is equal to how much? 0.75 square plus 1.2 square root. So with this 0.75 plus this radius is equal to 0.75 square plus 1.2 square root of this will give you this radius plus this will be this one. The principal stresses at a point in a bar are this one. The accompanying maximum stress intensity is how much? So maximum shear stress is sigma 1 minus sigma 2 by 2. This is the formula. This is sigma 1, this is sigma 2. Maximum shear stress is equal to radius, and this means sigma 1 minus sigma 2 by 2. So sigma 1 is 160 minus, and this is compressive, by 2. So it will be 240 by 2 means 120. Means this one is the right option. An element of a certain material in a plane strain is this one. This is epsilon x, epsilon y, and this one. What is the maximum shearing strain? So formula for this is Ex 800, this is Ey 400, and this will be half of this one, means 300 by 2. It is 150. This will be 150. So this will be my Mohr circle of a strain. So maximum shear strain will be how much? This will be 5 max by 2. This 5 max by 2. And this will be equal to how much? This will be equal to the radius. And this radius is equal to how much? This is 800, this is 400. So this will be 800 minus 400. 400. So it will be 200 plus 200. This is 200 square plus this 150 square. I will get this radius. So this will be equal to the radius, and radius is equal to 200 square plus 150 square. And this will be, if I take 10 square common, then Mm, this will be 20 square. Mm, 200 means 2 into 100 whole square plus 20 into 10 whole square. This will be 15 into 10 whole square. So this will be 10 into 20 square plus 15 square. This will be 400 plus 225 means 625, and this is 10 into 25 means 250, and this is equal to 5 max by 2. So 5 max will be 250 into 2. So this will be 500 into 10 is to power 6. So this one is the right option. At a point in the web of a girder, the bendings and the shearing stresses are this one. The principal stresses are how much? Bending stresses and shearing stresses are, so it is like this. So it is 90 and shear stress is 45 is 45. Let's draw a Mohr circle. So it will be like this. This is 90 here. It is 0 on this plane, and this is 45. This is also 45. So this will be my Mohr circle. So principal stresses will be how much? This will be major principal stress sigma 1. This will be sigma 2. So sigma 1 will be, this is 0, this is 90, so it will be 45, 45. This is 45. This is also 45. So it means this square plus this square, it will be 45 root 2. This will be the 45 root 2 is the radius. This 45 root 2 plus this 45, I will get sigma 1. Sigma 1 is equal to 45 plus 45 root 2. So it will be 45, I take common, it will be 1 plus root 2. So it will be 45 into 2.141. Root 2 is equal to 1.414 plus 1 is equal to 2.41. So it will be approximately 2.4. So 45 into this will be how much? Mm, it will be, I think some mistake is there. Oh, this is a 90. This is not 40. This is 90. This is 45. So this will be 45, 45. And this 45 root 2. This is the radius. Principal stress will be 45 plus 45 root 2. 45 plus 45 root 2. it will be 45 plus root 2. So if I take 24, it will be 24 into 108 something. So 108 something will be the maximum principal stress, and this will be tensile, and this will be compressive. So this one is the right option, as this is tensile. So this one is the right option. In a two-dimensional stress system, principal stress is, this is sigma 1, sigma 2. Yield stress in both the simple tension and compression is this one. This is a Poisson ratio. What will the value of the sigma 2 according to a maximum normal strain theory? What maximum normal strain theory says? Sigma 1 minus sigma 2 upon m is equal to Fy. Sigma 1 is 200 minus sigma 2 is, this is compressive, into Poisson ratio 1 upon m. This is equal to this 250. So obviously this will be 200 plus sigma 2 upon 4 is equal to 50. So sigma 2 will be, this will be 50 into 4. This will be 200. This one is the right option. A specimen is subjected to pure shear regime of intensity tau. The resulting tensile and compressive stresses which occur on plane inclined at 45 degree to the direction of a shear stresses will be. So this is a case of pure shear. This is tau, this is tau. If I draw a Mohr circle, it will be so resulting tensile and compressive stress is sigma, which occurs on plane inclined at 45 degree to the direction of a maximum shear stress. So 45 degree of this will be, means this is a maximum shear stress. So 45 degree means it will be 2 times of this. So this will be tau. So tau will be the answer. This tau, this is tau. A mild steel is subjected to axial force. So this, what would be the normal stress on a plane in making an angle of theta? So obviously it will be half of this. As we know, this is half of this will be 50. So this one is the right option. State of stress on an element in plane stress is shown in this. What is the value of the sigma if the value of the principal stresses are this one? So it's like this. This is 150 and this is Q, this is sigma, and this is Q. So it will be like this. Mohr circle. The value of the sigma mix is 164 and 36. This is sigma 1 is equal to 164 and this sigma 2 is equal to 36. I have to find what is the value of the sigma. So this sigma is from here to here. So this I have to find. So this will be equal to how much? This 164 is the major principal stress. So this will be equal to how much? This will be equal to 150 plus sigma. This will be the center. 150 plus sigma average plus this is 150 plus sigma by 2, this plus this one, this is the radius, and this is equal to 150 minus sigma by 2, and this is q, plus 150 minus sigma by 2 whole square plus q square. This will give major principal stress, which is 164, and minor principal stress is 36. This will be 150 plus sigma by 2, which is this one, minus this radius. So this will be 150 minus sigma by 2 whole square plus q square. If I add both together, then I will get this cancel each other. This will be 200, and this will be 150 plus sigma, and sigma will be 200 minus 150, it is 50. So sigma will be 50. So this one is the right option. The state of stress at a point in 2D stress system is characterized by direct stresses of 40. This is compressive and this is 80. This compressive means this one is 40 compressive and this is 80 tensile. Two mutually perpendicular planes, shear stress is absent. So shear stress is absent means this is principal stress case. The maximum shear stress at this point along a duly identified plane is how much? So if I draw a Mohr circle, this is 40 plus 80, this is the origin, total is 120. So 120 means its center will be half of this, it will be 60, 60. So this is the radius, and this radius is q max. So q max is equal to this radius, which is equal to 60. It means this is the right option. And electrical resistance strain rosette indicates a strain of this and this along the x, y and 45 degree. What is the shearing strain? Gamma xy. As we know, epsilon theta is equal to epsilon x plus epsilon y by 2 plus epsilon x minus epsilon y by 2 cos 2 theta plus gamma xy by 2 sin 2 theta. So in this case, this when it is 45 degree, when theta is 45 degree, my E theta is equal to 500 is equal to fx x plus epsilon y by 2. What is this? It is minus 400 plus 800 by 2 plus, and this will be cos 2 theta. Cos 2 theta means theta is 45, so this will be cos 90, as cos 90 is equal to 0. So this will be 0 plus gamma xy by 2 sin 2 theta means sin 90. Sin 90 is equal to 1. So this will be 500 is equal to, this is 800 minus 4, this is 400 by 2 means 200 plus gamma xy by 2, this will be 300 into 2 is equal to gamma xy. So this will be 600. So this is one is the right option. So this is the biaxial stress system. I have to find out the normal stress in this plane. This is the plane. If this is 45, this is also 45 degree. So if I draw a Mohr circle, it will be like this. This is 60. This one is compressive 40. Shear stress is 0. So this will be my Mohr circle. And 60 plus 40 is 100. So center will be here. It will be 50-50. So means I have to know the normal stress when theta is 45. So from here 2 theta means 2 into 45 means 90 degree. So this will be the maximum shear stress, and I want to know the normal stress. Normal stress, what will be the normal stress from this point to the origin? This will be the normal stress. And what will be this? As we know, this is 40 and this one is a 100. This is 50 and this one is 40. So 50 minus 40 means this 50 minus this 40 is 10. So 10 will be the normal stress. It means this one is the right option. A machine element develops principal stresses of magnitude this and this. What is the maximum magnitude of P before the metal reaches the yield stress Fy as per distortion theory? So what basically maximum distortion theory says? Sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equal to Fy square. So in this case, this is 2p square and p square minus 2p into p, that's equal to Fy square. So this will 2p square means 4p square plus p square minus 2p square is equal to Fy square. So this will be 3p square is equal to Fy square. So root 3 p is equal to Fy. So p is equal to Fy upon root 3 means my value of the p is equal to Fy upon root 3 means this one is the right option. A structural element is subjected to two-dimensional stress system where sigma 1 is equal to this, sigma 2 is equal to this. Sigma 2 being compressive, the yield stress in both the simple test is this one and mu is the, what is the, as per maximum strain theory, sigma 1 minus sigma 2 upon m is equal to Fy. Sigma 1 is equal to 255 minus sigma 2 is compressive into this Poisson ratio. Poisson ratio is 0.25. This is equal to this Fy is equal to 250. So some mistake is there. It is not 255. This is 225. So this is 225 means 225 plus sigma 2 by 4 is equal to 250. So sigma 2 by 4 is equal to 25 and sigma 2 is equal to 25 into 4 is equal to 100. It means this one is the right answer. Which of the following Mohr circle represent the state of pure shear? Yes, as we have discussed, this is the case of pure shear. So B is the right answer. The failure of a mild steel specimen of circular cross section subjected to torque along its cross section. Yes. In case of normal bending, it will be 45 degree to the normal plane, and in case of torsion, it will be along the cross section. Yes, this is road. Failure occurs on a plane of maximum shear stress and the mild steel is relatively weak in shear. Yes. So both are correct and this is the correct explanations. This one is the right answer. Which of the following statement are correct for stresses acting on mutually perpendicular faces of a plane element? The sum of the normal stresses in mutually perpendicular planes is equal to the sum of the principal stress. Yes. As we know, if this is P1, this is P2, then sum of this P1 plus P2, that will be equal to sum of the, if this is Pn, and if I draw, then sum of this is, suppose this is Pn, this is Pn dash. So sum of this and this will be equal to P1 plus P2. So in any of the plane, the sum of the normal stress, that should be equal to each other. The shearing stresses in two mutual perpendicular planes are equal in magnitude and direction. Two mutually perpendicular plane means, if there are two mutually perpendicular planes and shear stress is there, so these are equal to each other, but they are not equal in direction, they are opposite in direction. So this one is the wrong, means third is maximum shear stress is half of the difference between the, yes, as we know, Q max is equal to sigma 1 minus sigma 2 by 2. So this is root. So 1 and 3 is the right option, 2 is wrong. A square element of structure part, this is the case shown in the figure, on a plane BD, the intensity of the resultant stress due to these cases will be how much? Resultant stress. So this is 300, this is 100, so it will be, radius will be 300 minus 100, 200, this is dia, and radius will be 150, radius will be 100, this is 100, this is also 100. So intensity of the resultant stress due to these conditions. So as we know, this on BD plane, my theta is 45 degree. So this is 2 times of theta, means this is 90 degree. So resultant stress means normal resultant stress will be, this is 100 and this will be 100 plus. So this is 200, 100 plus 100, and this is 100. So resultant will be 200 square plus 100 square root. So it will be 100 into 2 whole square plus 100 square. So 100 square means 100 plus, it will be 4 plus 1 root of 5. So it will be, root of 5 will be, it will be 100 root 5. It means this one is the right option. A structural element is subjected to pure shear. This is a case of pure shear as shown in the yield stress is both in tension and compression are this one. So according to maximum normal stress theory, maximum principal stress theory, factor of safety in tension and compression are respectively how much? So as we know, in this case, this is a case of pure shear. So there will be tension here and it will be compression on this side and the value will be same. So these are my maximum principal stresses. So this is 80 and this is 240. So factor of safety will be 240 upon 80, it will be 3. So it will be 3 in both the cases, in compression and as well as in tensile. So this one is the right option. The principal stresses at a point are 80 and 40, both tensile. The yield stress in simple tension of this material is this one. So according to maximum principal stress theory, what maximum principal stress theory is this? When this 80 becomes this one. So this 200 upon 80 will be the factor of safety. So this will be 2.5 and so according to maximum principal stress theory, it is 2.5 and maximum shear stress theory will be how much? maximum shear stress will be 80 minus 40 by 2, sigma 1 minus sigma 2 by 2. This is maximum shear stress, and this will be equal to Fy upon 2. So it will be 40 minus 80 minus 40 by 2. So this will be 80 minus 40 means 40, and this Fy is equal to 200. So factor of safety will be 5. So this is the right option. The principal stresses at a point are this is compressive, and the stress at elastic limit for the material in simple tension is this one. So according to maximum shear stress theory, what's maximum shear stress theory? Sigma 1 minus sigma 2 by 2 is Qmax is equal to Fy by 2. It means 2 sigma minus, and this is compressive, it will be minus sigma by 2 is equal to 210 by 2. So this will be 3 sigma is equal to 210, sigma is equal to 70. Means this one is the right option. If an element of a stress body is subjected in a state of pure shear with the magnitude of this one, the magnitude of maximum principal stress theory at this is a case of pure shear. So in case of pure shear, this is 80. So this is 80. So this will be tensile, this will be compressive. This is a pure shear, this is 80. So maximum principal stress theory will be 80. So 80, this is the right answer. The two perpendicular axes x and y of a section are called principal axes when moment of inertia about the axis are equal. When product of the inertia is equal to 0, a product of moment of inertia is equal to 0, or moment of inertia about one of the axes is greater than this one. So this one is the right of product of the moment of inertia ix y is 0. This is the right answer. Pick the incorrect statement. This is a gate question. Pick the incorrect statement from the following four. On the plane which carries maximum normal stress, the shear stress is 0. Yes, this is a principal stress. Principal plane are mutually orthogonal. Yes, this is also. On the plane which carries maximum shear stress, the normal stress is 0. This is wrong. On the plane of maximum shear stress, there will be a normal stress, obviously. So this is a maximum shear stress. So this will be some normal stress. So this is wrong. The principal stress axis and principal strain axis coincide for an. This is also wrong. Principal stress cases and principal strain. So it means this A and B both are correct. Oh. Oh, this is wrong. Pick the incorrect. Incorrect. So incorrect means this will become my answer. It will be C. The state of two-dimensional stress acting on a concrete laminar. This. So which causes cracking of concrete, then the tensile strength of concrete will be how much? This I think we have solved earlier. This is a repetitive question. So this will be 2.7 as we know. This is 1.5 and this is 1.20. This is 1.2. This question is repeated. So it will be 0.75 and it will be 0.75. So maximum principal stress, this will be this plus this 0.75 plus radius. It will 0.75 square plus 1.2 square. So it will be 2.17. This one is the right option. So in a two-dimensional stress analysis, the state of stress at a point is this one. sigma x and sigma y I have to find. Suppose this is the theta, then this AB is 4, BC is 3, AC is 5. So sin theta will be 3 by 5, cos theta will be 4 by 5. Now, as we know, this is 70 tau and this is 120. So, as we know, the normal stress is equal to 120. This 120 is equal to sigma x square sigma x cos square theta plus sigma y sin square theta. This is the formula. And this shear stress 70, this will be equal to minus sigma x minus sigma y by 2 into sin 2 theta. So with this equation we can find it. It will be 120 is equal to sigma x cos square theta, means sigma x cos square theta is equal to how much? It will be this one plus sigma y sin square theta will be, so there will be one equation, it will be 120 into 25 is equal to 16 sigma x plus 9 sigma y. So this is my equation number 1. Other equation I can find from here, it will be 70 minus I can take here, it will be sigma x minus sigma y, this will be by 2 and this will be 2 sin theta cos theta. So sin theta into cos theta will become, will be minus 70 is equal to sigma x minus sigma y into sin theta into cos theta. It will be this into this will be 12 upon 25. So this will be minus 70 into 25 is equal to 12 sigma x minus 12 sigma y. So with this there are two equations and two unknown, sigma x and sigma y we can find from the equation, and it will be sigma x will be 67.5 and this will be 213.3. So this we can find. This is the right option. The component of strain tensor at a point in a plane strain case can be obtained by measuring longitudinal strain in the following direction: along any two arbitrary directions, along any three arbitrary directions, along two mutually orthogonal, and along any arbitrary directions. So in case of strain rosettes, strain gauges, it will be three arbitrary directions. So this one is the right option. If the principal stresses in two dimensional cases are this one and this one, then the maximum shear stress will be how much? As we know, this is minus compressive, this is 20. So obviously 20 plus this is 30. So this is my Mohr circle. This is 30. So its radius will be half of this. This is 15. So this will be the maximum shear stress, which will be radius 15. It means this one is the right option. Mohr circle for the state of stress I defined by this matrix. What it says, center is how much? If I draw this, then it is like this. So sigma x is equal to 30, it is tensile. Sigma y is also equal to same, and shear stress are 0. It means this Mohr circle itself is a point. This is a point. So its coordinate will be, this x coordinate is 30 and this is 0. So 30, 0, these are the coordinate, and its radius is obviously 0. So this one is the right option. And actually loaded bar is subjected to normal stress of this one. The shear stress in the bar is how much? As we know, this is 173 Mohr circle for this. This is 130 on this plane, it is 0. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is 173 upon 130. So this is 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130. So this is my Mohr circle, and shear stress will be 173 upon 130 this equal to radius. This is equal to half of this. So this will be 173 by 2. It will be 86.5. So this is the right option. Consider the following statement: on a principal plane, only normal stress acts. Wrong. Yes. Only normal stress act. Shear stress is 0. Yes. Principal plane, on a principal plane, both normal and shear stress. Wrong. Shear stress is 0. On a principal plane, only shear stress acts. This is also wrong. Isotropic state of stress is independent of frame of reference. So it means isotropic state is independent. Yes. This is also. So 1 and 4 is the right option. So this is the right option. The major and minor principal stress at a point are this and this respectively. The maximum shear stress. Yes. If I draw, then this is 3. This is minus 3. This is my Mohr circle. So maximum shear stress will be this one, and this will be equal to total is 6. So this will be the radius. So this will be 3, and this is, so maximum shear stress is equal to 3. So this one is the right option. If a small concrete cube is submerged in deep still water in such a way that the principal pressure exerted on all the faces of the cube is P, then the maximum shear stress developed is. So in case of, this is a case of hydrostatic pressure water. So in case of hydrostatic pressure, my shear stress is always 0. So this one is the right option. The state of 2D stress at a point is given by this. So sigma x is, so maximum shear stress will be equal to how much? So this is sigma x is equal to 100, and shear stress is equal to how much? It is 30, and sigma y is 30. Sigma y is 20. This is 20, and this shear stress is also 30. So this will be my Mohr circle. So maximum shear stress in this case will be how much? This will be my maximum shear stress, Q max, and this will be equal to radius. So this is the radius. So this is equal to radius, and how much it will be? This is 100. This is 20. So it will be 100 minus 20, 80. It means this one is half of this, 40, 40. So this is 40, this is 30. So 30 square plus 40 square is equal to this one. So radius is equal to 30 square plus 40 square, and this will be 50. So this arm is Q max. Q max is equal to 50. So this is the right option. Two triangular wedges are glued together. So this is the case. Normal stress I have to find. Yes, it is 100 tensile, and on this side it is 100 compressive. So shear stress is absent. So this is my Mohr circle. So normal stress means this is the 45 degree. So I have to rotate from 2 times of theta. So 2 times of theta means 2 into 45, it is 90 degree. So in this case, this is the origin. My normal stress is 0. It is 0 here. It is only the shear stress. So the answer is 0. For the plane stress situation, this one, the maximum shear stress will be how much? As we know, Mohr circle, this is 50. This one is also 50, and both are tensile, and shear stress is absent. So this will be just a point. The point is a Mohr circle. This simply is a point. It means it is the maximum shear stress, and the plane on which it acts are. So obviously, in this case, maximum shear stress will be, since it is just Mohr circle is just a point, so maximum shear stress is equal to 0. and it will be 0 in all the directions. So this one is the right option. Yes, this is a case. Major principal stress is 10, then shear stress is equal to how much? If I draw a Mohr circle, this is 5 tensile and shear stress is tau. Suppose this is tau, and on this plane my normal stress is also tensile 5. So this is fair, but this shear stress is upward. So if I draw a Mohr circle, it will be like this. If this is 5 from here, and oh, this is wrong. Five. This plane also it is. So this will be my Mohr circle. This is tau, this is tau, this is also equal to shear stress. So major principal stress in this case, this is the major principal stress, and this is equal to 10. So obviously this is 5 from the origin, so this will be 10 minus 5 is 5. This is equal to the radius, and this radius is equal to q max. So maximum shear stress is 5. So this is the right answer. So I hope you enjoyed my lecture. So thank you very much and good night.